Hello and welcome to the YouTube channel Decreations Resources. Under the playlist Decreations Mathematics, we are looking at different concepts from maths, particularly complex analysis. So let us solve a question based on complex integration. Here you can see that you have to evaluate this integral and three cases have been specified. Case 1 is that C is the boundary of the annulus between circles of radius 1 and 3. In the second case, C is the boundary of the annulus between the circles of radius 1 and 4. And in the third case, C is the circle of radius capital R which is greater than pi. Now, when you look at the integrand, you can understand that the possible singularities will be at z is equal to 0 and z is equal to pi. Now, let us consider the three cases. In case 1, the region specified is annulus region. That means we need not worry about z is equal to 0. It will be excluded. What about z is equal to pi? Pi has the value 3.14. So again, even that will lie outside the circle of radius 3. So in case 1, both the singularities need to be excluded. We can use Cauchy's theorem because f of z is analytic inside and on C. So directly we can say that the answer is going to be 0. What about case number 2? In case number 2, again it's annulus region, so we need not worry about z is equal to 0. But the radius specified for the second circle is 4. So pi, which has value 3.14, will lie inside that. So you will need to evaluate residue at z is equal to pi. Now, we know that e raised to I pi is basically cos pi plus I sin pi. Sin pi is 0, cos pi is minus 1. So that will leave you with minus 1 and in the denominator it will be pi. So the residue will be minus 1 upon pi. So the answer is going to be 2 pi I into minus 1 upon pi, which is the residue. So answer will be minus 2i. What about the third case? Now in the third case, it has been said that C is the circle of radius capital R greater than pi. The fact that it is a circle tells you that you have to consider the singularity z is equal to 0 and the radius is greater than pi. So even pi is going to lie inside. So you will have to consider residue at pi as well. So calculate residues at both 0 and pi. Add them up and multiply it by 2 pi I. So eventually the answer that you will get will be minus 4i. So depending on how C has been specified, the answer is going to differ.